consider this topic in the textbook kind of supplementary. I'm sure that most of you are fairly comfortable and familiar using calculators and other technology to draw graphs. This particular exercise, this example in the textbook, asks us to do some very specific things, and that's because with graphing calculator technology, the way the graph is rendered can be confusing depending on how you look at it, depending on the window size you use. So in your graphing calculator, if you graph f of x equals the sine of 50x, then depending on the width of your window, you'll get a different graph. Now, that doesn't happen in Desmos, for example. That's the technology that I'm going to use to demonstrate this in a minute. It doesn't happen in Desmos because it uses a different rendering process. But there are some very handy tools in Desmos that some of you may not know about. Now, I'm perfectly happy with you using Desmos to do your homework, and in an online class, you're welcome to use it to take tests as well. In a face-to-face class, you won't have that option, but there's still some pretty powerful stuff that Desmos is able to do. So I'd like to take just a few minutes and go over some of those features. I'm going to start by graphing this function here, the one we're asked to graph, y equals, or f of x equals, the sine of 50x. Okay, so here's my Desmos window, and I've already put in f of x equals the sine of 50x. So when I turn this on, you can see what my graph looks like. One thing you probably already know about it is that if you press and hold this circle here, you can choose a different color for your graph. I like blue. It's kind of neutral. You can also make it a dotted line. That doesn't work very well with sine and cosine. A dashed line or a dotted line. Let's stick with solid. And you can make the line thinner or thicker. You can also turn the graph off completely just by clicking. You need to click and hold to change the color. Now, the thing I really want to show you is how to zoom in, not quite in the way that you might be expecting. We know about zooming in and zooming out. And did you know that once you zoom in or out, this home button will take you back to Desmos's default zoom? That's where, at least on this screen, every box has a measure of 1 unit in both directions. If I widen my sidebar here and press zoom in and then home, then my y-axis jumps to having a unit measure of 2 for each big box. Let's go back to 1. Now there are a couple of things we'd like to do here. One is look at this graph more closely. This one's not too bad. Once I zoom in, did you know about this? If you click on the graph and then click on one of the points, it will show you the values to 2 or 3 or 4 decimal places, depending on how dense the graph is. It'll show you the values of the zeros, the x-intercepts, and of the maximum and minimum y values. You can see here those points, the coordinates of those points. That particular one is 0.597, comma -1. Now, if I zoom in far enough so that I can see some detail along the x-axis, I lose the height of the graph. I can't see the top or the bottom of the graph. So I'm going to press the home key to take me back to Desmos's default zoom, and then I'm going to show you something really kind of cool. Now, some of you may already know about this trick, but for those of you who don't, I know that when I first learned it, it blew my mind. I can zoom in or zoom out, or I can choose just to zoom in or zoom out in one direction. For example, here I'm just zooming out in the x direction. Perhaps I'd like to zoom in the y direction, and I can do that as well. Now the question is, how did I do that? And the answer is, when I hover near the x-axis and press the shift key, I get this new horizontal cursor. And then as I have to keep the shift key pressed as I do this, I can choose to zoom in and out as much as I want, just in one direction. And when I hover and press the shift key near the y-axis, I can stretch or compress the y-axis as much as I want. I hope if you take nothing else away from this video that you'll appreciate the difference that can make to graphs like this. There are a couple of other things I want to talk about though, and those are some of the features in the settings. Notice that right now my graph is labeled in terms of decimals. Well, sine and cosine are really kind of, especially when you're talking about radians, they're really more naturally discussed in terms of pi. I'm looking for roughly 6 here. Because I want to take my graph from 0, which is down here, to a little over 6, which is here. But I want to do it in terms of radians. So I'm going to go to the Settings button, Graph Settings, and I'm going to change the step to pi over 12. Now you can change it to pi over 2 or pi over 6 or anything you want. But I choose pi over 12 because pi over 12 and 5 pi over 12 are the missing angles, if you will, in the first quadrant. So pi over 12 is kind of a nice step to use here. Now when I get rid of that, I can either do that by clicking on the tool again or just clicking away. I get, here's my 0, I get 0 to 2 pi, and now it's in terms of pi. Let's stretch that out just a little bit. So I can see between 0 and 2 pi on my graph, and I can make it as tall or as short as I want. You can also, in the settings, in the graph settings, you can also switch between radians and degrees. Notice that when I change between radians, which is what I was in before, and degrees, which is what I'm in now, my graph gets considerably larger. And that's because there's roughly one cycle of sine. That's because my entry value, let's choose pi, because we know that's just a little over 3. I'm now entering about 3 degrees. So I'm getting an output that is very different from what happens when I enter, let's go back into radians, when I enter 3 radians. 3 radians is pi radians, a little over pi, a little less than pi radians, right? I'm getting a different value, a different output value there. So you can switch between radians and degrees. Most of the time, you're probably going to want to be in radians. Okay, I'm going to get rid of this graph because I want to use f of x to mean something else. Actually, maybe I'll just change it to y for now, and I'll turn it off. Now I'm going to graph f of x equals the sine of x, and g of x equals the cosine of x. And then I'm going to add these two graphs together, not by typing out h of x equals the sine of x plus the cosine of x, but by typing out h of x equals f of x plus g of x. You can see that this equation takes the f and the g that I defined up here and adds them together graphically here. Now I can turn those off if I want and change my scale a little bit. I'm using the shift key again there. And I can see I don't quite have a full cycle there, do I? So let's scoot it over so that I can see this is a sine plus a cosine. So I have a couple of options. I can think of this as starting here and ending here. Or I can think of it as a cosine, which starts here and ends over here. Your choice. Now I've just done that to show you that you can add together sines and cosines. But let's see what happens if we change the sine of x to the sine of 2x. That introduces quite an interesting pattern in the graph. Can we see the whole thing? Well, it looks like if you start here at 1, it goes up to about 1 3/4, down to negative 1 3/4, up to, looks like about 0.4, down to negative 0.4, and then it goes up to 1 3/4, down to negative 1 3/4, and it repeats. So let's see if we can figure out where it repeats from and where it ends. If we call this our starting point, then the next time we get to 1 is here, and that's where the pattern starts. If I'd like to highlight one of those cycles, then I can add a copy of this graph. I'm going to call it k of x instead, though. This is another neat Desmos trick. open curly brackets and say that you want x to go from 0 up to whatever this value was. Let's see what, oh, it's 2 pi. Okay, so we're going to say 2 pi. And now you can see, let's change the color on this one. Yeah, let's make it yellow. Now you can see this black graph, this heavy black graph, is exactly on top of the orange graph, but it only lives between 0 and 2 pi. Right? It stops at x equals 2 pi. So a couple of neat tricks here. One is that you can take two functions and define a third as the sum or difference of those two functions. And then the other is that you can take just a section of a graph and use it as a highlighter. Now I can either just show one cycle by turning off the whole graph, or I can highlight one cycle by leaving the black graph, which by the way is darker than the graph underneath it, so it's easy to see. Right? I can leave that turned on and leave the graph underneath it turned on so I can see the whole thing, but I can see what one cycle looks like as well. So now I can play around with sine and cosine quite a bit. What happens if I add an amplitude of, say, 3 to cosine? Well, clearly it changes the length of the height of the graph. So let's pull it down so we can actually see where we get to. We get to about 3.5 now. What happens if I change the amplitude of sine to 5? Well, I need to bring my graph down again. What if I add a 4 to my argument for cosine? What if I change my argument for sine to a 3? All kinds of interesting things happen. Make that a 7. As you can see, the more I get in my argument, the more wiggles I get between 0 and 2 pi. And that makes sense because we talked about the fact that these numbers here change how many times you get a cycle of sine or cosine. Well, I've got a cycle of sine and a cycle of cosine because I'm adding the two graphs together, but these are the things that are affecting that, right? The more I have here, the more cycles I have here. I hope you've enjoyed this as much as I have.